So this is a skid that we've put together for SAP and Intel. They asked us for a skid that they could interface their software with. Their software will allow them to generate tickets, work order tickets for maintenance, preventative maintenance, other situations like that. So they asked us to put this together. So we have a tank back here, and that flow comes out down through the bottom, down into the pump here, and then back up, back into the tank. They wanted a number of sensors on it. So when the water comes out, we have a pressure sensor here and a manual gauge. It goes back into the pump. We have a vibration sensor here, temperature sensor here, pressure sensor here with a manual gauge for the pressure. Then we have a flow meter here that then is transmitted back. You notice these sensors are wireless. This one has a battery in it, so there's no wire. These have batteries in it, so there's no wire. This one has power to it, as well as these transmitters up here. When we turn it on, the water comes down and then gets pumped back up, and we have valves on it so that we can adjust the conditions of the pressure, and we can see the changes in the pressure along the way, as well as the flow here. And I'll show that to you in just a moment. Inside, mostly just power distribution, but we do have a current clamp here so that we can measure the current going to the motor, and we can get some information off of that as well. These wireless sensors all go back to this gateway. This gateway then allows them to interface their software and get information from it back up into it. It could be a SCADA system, in this case it's SAP's system, and all those wireless sensors go back into there. This flow meter just puts out pulses to this box here, which counts the pulses and the flow rate. It then converts it to 4 to 20 milliamps, which goes up here to this transmitter. That 4 to 20 milliamps is wirelessly transmitted back there. We have a tank level sensor here, which is 4 to 20 milliamps back out to this transmitter as well. And then this is the actual wireless antenna for this IoT gateway here. Lastly, we have one other set of sensors, which are not connected to anything. But these sensors, here's another wireless node, have a displacement on them. So there's two of them, also has a temperature sensor, but the displacement stretches here. It could go on this motor here. If this motor were to be offset from the coupler for any mechanical reason, we can measure that displacement. It could be put on pipes so that if the pipes slip or bulge or for whatever reason are mechanically displaced, we can measure that. So I provided this so that they could play that in their software. Notice that these sensor nodes are magnetic, so they can be just plugged on most anywhere. So we're going to go ahead and turn this pump on. We can close this, which increases the pressure here. The flow rate stops here. We can close this valve here, which doesn't do anything by itself because I have no flow here. And I open this back up, open this back up. Now I'm going to go ahead and shut this valve. And it causes cavitation in the pump. See the bubbles here, and the pressure falls to a vacuum here. We can see it here, but we'll capture it in the software from this guy here. I closed it. I opened it back up. Open it back up there. Now it's back to normal. Over here, the software, this is using what's called Node Red. It has these flows in here where we put in the sensors and capture the data, and then we can see the data that's coming out of each one. And this can be graphed on here, but it can also be graphed and captured and everything back up at the software level.